is using a slightly different method using Jensen's inequality. So you have a random variable x. Let's suppose that the expected value of x is mu. The variance of x is sigma squared and it exists. We need that. Median is theta. So we need to prove this. So to prove mu minus theta is less than or equal to sigma, which is basically that median is within one standard deviation of the mean. So one thing we know is that median, that is theta, minimizes this quantity, the expected value of the absolute deviation from x, which basically means that for any quantity, including mu, this equality must hold. Now remember Jensen's inequality, which says that if gx is convex, the function of the expected value must be smaller than or equal to the expected value of the function. Or vice versa, gx is concave, the inequality changes direction. We know that absolute value of anything is convex and the square root of anything is concave. Keep these things in mind. Now, consider this quantity on the left side. All right, now we take the absolute value of this quantity. We haven't done anything because expected value taken within the parentheses will give you expected value of x minus theta, which is basically mu minus theta. So nothing has happened here yet. But now, what you do is apply the Jensen's inequality to the absolute value function, which basically means that this is less than or equal to the expected value of the absolute value. Now, apply this inequality, which says because median minimizes this expected value, it has to be smaller than or equal to the expected value of x minus mu, absolute value of that. So this equality holds. Now, what I have done here is nothing. I just took the square of it and took the square root of it. So that this equality holds. Apply again the Jensen's inequality for square root function, which is concave. Therefore, the inequality still remains in the same direction. So the square root of this is what you get from there. Of course, I've rewritten the absolute value square as just simply the square because that's true. Now this by definition is the variance, and the square root of variance is sigma, and the proof is complete.